Guys, you guys probably already know how to work with numbers like smaller ones like 1, 3, 7, or 9, or even 2 or 3 digit ones like 115 or maybe 345 or something like that. But what if I were to tell you about other numbers that are bigger and how to deal with them? Well, some properties of them are ones you can do with them. Like, for example, I'm going to pick 88499557522123889386046786710357863796814159292035398293. This number has 110 digits. And this is more than the amount of atoms in the universe. It might seem like you can't do anything with it, but what if I were to tell you a bit more about this? The reason why I picked it is because it's a cyclic number. In my video about cyclic numbers, I've told you about cyclic numbers. And this one is where you plug 113 into the formula for one, and you get this massive number. Multiplying this number by a number up through 112 will give you a different rotation of this number. But if you're going to multiply this number by 113, you'll get a string of 112 nines. So this number might as well be divisible by 99 because you have an even number of nines. Which brings us to the segment, is it divisible by 11? Well, we need to add up all the odd digits of this number. So 8 plus 4 plus 5 plus 7 plus 2 plus 1 plus 3 plus 9 plus 8 plus 5 and so on. All the way down here. Until we end up with a sum like I showed you before. The sum of these odd digits is 252. Now do the same thing with the even digits. So you do 8 plus 9 plus 5 plus 5 plus 2 plus 2 plus 8 plus 3 plus 0 plus 3 plus 9, so on, all the way down here. And you also get 252. So the difference between these two is 0, which means it's divisible by 11. You can also check if it's divisible by 11 by seeing, like, if the difference between these two is divisible by 11. Well, 0 is divisible by 11 because dividing it by 11, you get 0. So, there we go. Let me prove it to you that it is, real quick. I'll calculate what it equals. Be right back. So from this, we can infer that it is indeed divisible by 11. Yes. So, divided by 11 gives you 80450522928399034593724859211584887 blah 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 blah. 108 digits. But that is not it. You can also do some more things about this. Like, you can imagine that this number factorial would be unimaginably huge. Like, even more than that. Like, it could probably be something like it close to a googolplex. So, if you want to find out how many zeros are at the end of this number factorial, all you have to do is divide it by greater powers of 5 until you get a result less than 1. So, divided by 5, you get this, and oh look, it's a rotation of that number. You have 176991150442477878610. Yeah. That is another rotation. That tells you that this is indeed a cyclic number, because the sequence is literally, I think, right here. Yeah, it starts right here and goes all the way to here, then goes back to 008849555575, blah, 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 blah. Same thing happens to you divided by 25. And this is a 108-digit number. This one has 109 digits. But divided by 125, I just put it in scientific notation for you guys, just as a little approximation. So, this number has this many zeros at the end of its factorial. And we're going to have to prove that by showing you this. Like, you're going to have to divide it until greatest of powers of 5 until you get to 5 to the 158th power, which is 0.323341. So you're going to have to discard the decimals of all of these numbers and add the whole numbers together. So this is going to be this number divided by powers of 5, all the way until 5 to the 157th power. And then you get something like this. And this is about what you get. Most calculators do not have enough room to fit everything, so they just simplify it like this. Yeah, so this number has literally it literally has 22 quintillion zeros at the end of it. It has more than that. It has more than 22 quintillion zeros at the end of it. Yeah, hence the exclamation mark, because that's the factorial symbol. Anyway, that's about it. There's some more things you can do with these numbers, like multiply it by numbers up through 112, and you'll get a rotation of it. So, and also, one thing I wanted to mention about this number is that you can see that pi is hidden. Look, 141592922. Doesn't go 2 2s. It just goes 0 after that. 0 3 5 3 9 8 2 3. So I covered that in a few videos I made. Like, I showed you can approximate pi with this. Like, what's 355 over 113? Well, it's 3.1415929203539823. Pretty close to pi, right? Yeah. So there you go. That's how you can work with big numbers that are bigger than the amount of atoms in the universe. Or just use coding or something else to figure it out. I don't know. It's up to you guys.